How a voltage follower works, either in JFET or MOSFET or BJT. For this, I'll just show you one simple example using BJT as a emitter follower. So, sometimes they call it also common collector. This is a typical circuit. So this is your VB and this is your RB. Typically for this, your gain is about 1. So you can take a look at the manuals that have been given to you. The AV is approximately 1, or the gain is approximately 1. What you have is that if this is your RE, what you will see from here is beta RE. So this is RE plus small re multiplied by beta RE. What you will see from here, this will be a huge multiplication. Let's say your beta is around 300, and let's say your RE is 1 kilo ohm. So now, looking into the base, what you'll see, if you have a load around here, the load will be reflected and it will be seen from base that you have the load of equivalent. This is equivalent to 300 kilo ohms. So now, in your experiment, what you will do is that you will do a voltage follower. Let's say you have a Zener diode. So this is your R to bias the Zener, and this will give you the V based on your Zener voltage. So let's say you have the what do you call thing? You say this thing is I think 4.7 ohms, or sorry, 4.7 volt, or whatever the Zener that you use in your lab. Then if you have your load around here, if your load is getting lower and lower, then your VB, if you throw away the Zener, will be this just RL divided by R plus RL. So what happened is that if your RL is getting lower and lower, you will see your V at this, the voltage divider, will be less than V around here. See, I just put some point A. So VA will be less than V Zener. Then what you will see is that your voltage that you get from this will be just like a voltage divider. So one way to reduce the load effect of the Zener is to have a beta multiplier in your emitter follower. So you'll have something like this. This thing, put a small resistor, just so this will be your regulated voltage out. This is just a small value, maybe around 1 or 2 kilo ohms. This is just for safety purpose, and this is your RE when there is no load. Your transistor is still functioning, so you just put a very high value of RE. So what you will see here is V Zener minus 0.7. So if your V0 is 4.7 volt, then what you'll see here is 4 volt. This will reduce the load effect seen by the Zener, as whatever that you see over here will be multiplied by beta. So now one way to increase the beta is by using Darlington pair, or use the Darlington pair to increase the IC. So this will be your second experiment. So now you need to find what is the suitable value for this, so that your Zener will be switched on. So in order to do this, you have to do this experiment first. You set what is the R value. You use your circuit simulator to find what is the suitable value for R in this case, so that your Zener will act as a Zener, because the Zener needs some amount of current in order for the Zener to work. Say this is 12 volt, so you have to find, so let's say this is 4.7 volt for the Zener, so you need to bias the Zener according to what is the current that is needed. Once you find what is the value of the resistor, then you need to connect to this as your voltage follower, so that you will have some kind of regulated power supply in your experiment. So this will be your second experiment. Same thing with for MOSFET, you take away this thing and you replace this thing with a MOSFET, because this will act as a VGS. So in MOSFET, your V out is just whatever your Zener voltage is. If you use MOSFET, you will have higher current, and whatever the Zener seen is just the very high impedance, and you can bias the MOSFET with a very high resistance, so that the it will complete the circuit, and also it will bias the to switch on your MOSFET. So in the case of MOSFET, what you will get is something like this. Same process. You need to bias your Zener first, and then this thing will be connected to this 1 mega ohm, and you just connect this thing to a MOSFET. So in this case, your V out is just whatever that your Zener voltage. Sometimes you need to put a protection diode over here, so that this thing will protect the MOSFET to limit the VGS. Sometimes they call it this thing a protection diode is built in, but this thing is just to limit the VGS. So this is your second experiment.